This lesson is on exponential function basics. By the end of this lesson, you should be able to graph exponential functions, understand how the different parts of the function affect the graph. Exponential functions, those whose exponents are variable, are extremely important in mathematics and science and engineering. So let's review many of the basic components of their graphs and behaviors. You need your calculator, so go ahead and grab it. Basic exponential functions, y equals b raised to the x power, and your b stands for your base. Your base must be greater than 0 and cannot equal 1. All exponentials have a horizontal asymptote, and that is very, very important, so make sure you highlight that. An asymptote is a line the graph approaches and does not cross. So let's consider the function y equals 2 to the x. We need to fill in the table and then graph it, and then write the equation of the asymptote. So grab your calculator. So go ahead and get a graph. Type in 2 raised to the x power. You're using your caret button. And hit enter. Notice this exponential is in quadrants 1. Right here is quadrant 1. This is quadrant 2. So this exponential is in quadrant 1 and 2. This is quadrant 3. This is quadrant 4. This exponential graph will never go into quadrants 3 and 4. You'll notice that it flattens out along the x-axis here. The x-axis is your asymptote, so this graph will never come into quadrant 3. So the horizontal asymptote is the x-axis, or y equals 0. So let's fill in our table and graph. So this is what you should have, your table filled in and your graph. So your horizontal asymptote is the x-axis, and notice I made it dotted, and your equation is y equals 0, and that is your asymptote. That is the line the graph approaches and does not cross. So why don't you pause the video and go and try exercise 2. It's exactly like exercise 1 except a different graph. So this is what you should have on your paper. You'll again notice that the x-axis is your horizontal asymptote. So your equation is y equals 0. You'll also notice if you compare the two graphs that the second graph is a reflection in the y-axis of y equals 2 to the x. So we took y equals 2 to the x, exercise 1, we reflected it over the y-axis, and we get our graph of 1/2 to the x. So if the base is fractional, then we notice it's a reflection in the y-axis. So exercise 3 talks about the domain and the range of exercise 1 and 2. So I'm going to look at my calculator. I notice that it seems to, and I'm going to change these to 1,000 just to see if you see any different. And my students know, wow, it looks like it's getting closer. It's just kind of hovering those. So maybe I'll change it back to 100 because it was getting too skinny. So we'll notice that as I go wider and wider and wider, it just hovers over the x-axis. It keeps getting closer and closer and closer to the x-axis. Is there any x value I cannot have? And the answer is no. So that means my domain is from positive infinity to negative infinity on the x-axis, because remember, domain is left and right. The range is bottom to top. Well, I know that this x-axis is an asymptote, which means the graph does not touch it. So that means the entire graph is above the x-axis, which means your range, y, the bottom of the graph is 0, but it does not equal 0, and the top of the graph is positive infinity. So our domain is negative infinity to positive infinity. You could also write a capital R for all real numbers, so either one, and my infinities look terrible. And then your range, the bottom was 0, so y is greater than 0. It does not ever equal 0 because that is your asymptote line. Are your exponential functions one-to-one? How can you tell? What does this tell you about their inverses? So the first question, are they one-to-one? Yes, they're one-to-one. How do we know they're one-to-one? Because it passes the vertical line test and the horizontal line test. We know that no x or y repeats. So that's how we know that it is one-to-one. What does this tell you about your inverses? Well, it tells you the inverse is a function. So if it is one-to-one, the original is a function, the inverse is a function. All right, pause it. See if you can graph number 5. Can you also include a table for me, please? Thank you. So I plugged it into my calculator and I got the table for 0, 1, and 2 for x. I notice it does go negative and it does go positive. And again, it's an exponential, so the domain is all real numbers. So I can plug any number I want in for x. And I notice that my answers are all going to be greater than 0. So all my y values, my range, is greater than 0. Determine the y-intercept. So at 0, my value is 7. So the y-intercept, the x value is always 0. So my y-intercept is 0, 7. Now to justify my work, I know that x is 0. So y equals 7 times 3 to the 0. Well, anything to the 0 power is 1. So 7 times 1 is 7. So that's another way to get the y-intercept, is to plug in x for 0. Does the exponential function increase or decrease? Well, if I connected maybe the 2 arrows, say, and just put my ruler there, I would notice that it is rising to the right. So it has a positive slope, so it is increasing. And explain, because it's maybe rising to the right. Or you could say positive average rate of change. Now it says create a rough sketch of this function, label the y-intercept, and I already have done that for you. Something I want you to notice, kind of previewing our next lesson when we have to write these equations. Notice when my x value is 0, my y value is the a. So this is a. Y equals a times b to the x. So my a value, my stretch or compress, is always the y-intercept when I don't have a shift up or down, okay? So we're going to do a shift up or down. We're not going to have to write these kinds of equations. Only this standard kind, a times b to the x. Now, how do I get the b value? Well, what do I do to 7 to make 21? Multiply by 3. What do I do to 21 to make 63? Multiply by 3. So this change is my b value. All right? So that's how you're going to, in the next lesson, write your equations. All right, let's look at one more exercise. And again, pause the video, plug it in the calculator, get a table, and then answer the questions. So hopefully you got the same table as I did, and you sketched your graph. How does this function's graph compare to that of y equals 1/3 x? So if you put those both in your calculator, you can see that they are the same graph, except the +4 one is up 4. So see how this has a y-intercept of 0, 1, and this one has a y-intercept of 0, 5. So all it did, the only difference between these two equations is this plus 4 on the end. And that means I shifted the graph up 4. So what does adding 4 do to the graph's function? The function's graph moved it up 4. Determine the graph's y-intercept algebraically. So again, the y-intercept, we know x equals 0. So y equals 1/3 to the 0 plus 4. Well, anything to the 0 is 1. So 4 plus 1 is 5. So we know our y-intercept is 0, 5. We graphed it, and notice I drew in a pink line. That shift up or down is your y-intercept. Your asymptote line. So our asymptote is this plus 4. So we know our equation of an asymptote is 4. If we looked in our table, we notice if we keep scrolling positively, eventually it just starts saying 4. That means we're getting really, really close to 4. We have to know that we don't ever equal 4 because this is an exponential equation. The calculator just can't calculate these values because 1/3 to the 66th power is so close to 4 that the calculator has rounded it. So we know the asymptote is at 4. Good luck with this. If you have any questions, please ask in class.